In the preceding section of the bitplatform tutorial, we incorporated the models, entity type configurations, data transfer objects, mappers, and controllers.
Following that, I proceeded to initiate a project using the admin panel sample. Upon reflection, I discerned a distinction between the controllers employed in our prior meeting and the exemplar controllers showcased in the admin panel.
For the sake of simplicity, we have omitted certain sections, and dependency injection is one of those aspects we plan to address now. The prevalent approach to dependency injection involves constructor injection. If we aim to implement this in the products controller from the preceding section, its code will undergo a modification. As you can observe, the resultant code is not particularly engaging. The approach employed in the preceding section involved leveraging C#12 primary constructors. Constructor injection, however, proves impractical in razor.cs files, necessitating the adoption of the inject attribute for injection purposes. To achieve a unified methodology throughout the entire project, BitSource generators offer a viable solution. Simply defining the class partially and incorporating the auto-inject attribute for any required injections, be it in Razor or C#, suffices to streamline the process. In addition, when employing inheritance, this code facilitates the implementation of dependency injection in the base class in a more straightforward manner. Consequently, in the final example embedded within the boilerplate itself, all components inherit from app component base, and all controllers inherit from app controller base.
That appears to be a captivating tool.
Yes, undoubtedly, BitSource generators enhance the performance of Blazor components by reducing reflection and additionally facilitate the creation of an HTTP client for us to make API calls on the client side. A concept we will delve into further in the upcoming sections. Now, let's explore another distinction between the code from the previous section and the boilerplate samples. In the prior code, we employed project method. This results in the direct creation of a list of product DTO instead of first generating a list of product models and then mapping it into a list of product divs. This approach is commendable for program performance. However, it still has a drawback where all product divs are gathered in an array before being transmitted to the client, leading to suboptimal memory consumption. A more efficient strategy is to return the response as a stream directly from the database. This involves creating product divs and transmitting them to the client in JSON format through a string. Thankfully, this capability is inherent in EF Core and ASP.NET Core Web API. To leverage this, it suffices to refrain from using two-array async. For instance, consider the scenario where you aim to retrieve categories associated with products. Instead of relying solely on converting to an array asynchronously or a list asynchronously, incorporate the following code. Now, envision a situation where the client specifically requests only the initial 5 categories. Alternatively, in scenarios such as presenting them in a data grid, searching them by name, or sorting them based on products count might be required. When the number of categories is limited, transmitting all of them to the client and executing these operations on the client side poses no issue. However, when dealing with a substantial number of categories, challenges arise. This is where the utility of enable query becomes apparent. Upon implementation in Swagger, you will observe that these values can be dispatched efficiently. $top is employed to specify the required number of categories, akin to the usage of take and link. $skip functions similarly to link skip, and its conjunction with $top provides the opportunity for pagination. $order by, akin to link's order by, facilitates sorting the output based on diverse properties. $filter, comparable to links where, allows for precise filtering. $select enables the retrieval of required properties, for example ID and name, when only these attributes of the categories are necessary. It is noteworthy that when requesting the initial 5 categories in the get non-empty categories operation, restricted to those whose name incorporates the character B, and exclusively seeking the ID and name properties. This substantially impacts the database query. Notably, EF Core optimally avoids computing the products count as it is not explicitly requested. The outcome is the retrieval of only the ID and name of the first 5 categories that have products, with the letter B in their name, ensuring optimal efficiency. Moreover, it's important to recognize that the client is confined to receiving data based on entitlements. For instance, whether employing a global EF Core query or implementing server-side filters, the client is unable to circumvent these restrictions. All client-specified filters are amalgamated with server-side filters using the logical and operation.
That's fantastic. How can I gain further insight into this?
The term denoting this concept is open data, and hitherto, you've assimilated nearly all essential facets. Its influence does not extend to routing or API versioning. However, it seamlessly aligns with Swagger. Irrespective of the nature of inputs destined for your action, OData remains accommodating. Only when certain elements, such as $top and others, are included in the query string, coupled with the configuration of enable query for the action, does it come into play. In cases where the output is an iQueryable sourced from EF Core, it seamlessly undergoes processing within EF Core to optimize the database query. However, if the output assumes the form of a list, its impact manifests through link to object, exerting influence within the realm of in-memory operations. It comprehensively accommodates various iQueryable providers, including Cosmos DB. Up to this point, our code closely mirrors the boilerplate sample. In the ensuing section, we will delve into the intricacies of exception handling and localization.